I'm Anil Kumar, and in this particular video we'll explore more about vertical asymptotes of rational functions. We have a statement here from a book. It says a rational function of the form f of x equals to px over qx has a vertical asymptote at x equals to c if qc is equals to 0 and p of c is not equal to 0. So the statement is a rational function of the form f of x equals to px over qx has a vertical asymptote at x equals to c if q of c is 0, that means if denominator is 0, and p of c is not equal to 0. So for that value of c, the numerator is not 0. In that case, a rational function will have a vertical asymptote. Now the question here is the above statement always true? You need to explain this, right? So let us explore and try to understand the definition. It says that f of x, it is ratio of these two polynomials, and that is what a rational function is, right? Rational function is ratio of two polynomials where denominator is not 0. Now, if the denominator is 0, that is to say that for a value x equals to c, if the denominator is 0, then what happens? Then we say there is a possibility of having a vertical asymptote, right? So what we are exploring here is that f of x equals to p of x over q of x, where for x equals to c, q of x, or I should say, is equals to 0. For x equals to c, q of x is 0. Okay, that means q of c is 0. That means q of c is 0, right? So if q of c is 0, then what happens? Then the possibility is that we could get a vertical asymptote, or we may not have a vertical asymptote. So there are two scenarios here. So one is no vertical asymptote, right? No vertical asymptote. And the other scenario is we can have a vertical asymptote. Now, when will you not have a vertical asymptote? You will not have a vertical asymptote if it says if the numerator is also equal to 0, right? If numerator is also equal to 0, then no vertical asymptote. That is what it is saying, right? But if the numerator is not equal to 0, then you will have vertical asymptote. That is what the statement is. I hope now the statement is absolutely clear, right? So in most of the cases, the statement is perfectly fine, right? Now in such cases, let me give you some examples here. We could have a statement, let us say f of x equals to, we'll take one example here, where f of x is equals to, let us say, x plus 1 over x squared minus 1. Now in this particular case, we do not have vertical asymptote at x plus 1, right? But we do have vertical asymptote at x minus 1. So this could be written as x plus 1 divided by x plus 1 times x minus 1, correct? Now what really happens is that they get cancelled off. Now since at minus 1 we have 0 both in numerator and denominator, we do not have vertical asymptote at minus 1, correct? So this is a good example to understand. So in this particular example, vertical asymptote is only at x equals to plus 1, right? But not at minus 1. What do we have at x equals to minus 1? So at x equals to minus 1, we have a hole, right? So we have a hole at x equals to minus 1, not a vertical asymptote. So that is the emphasis of this particular definition, right? So other way of saying this is that at x equals to c, if qc is 0 and pc is not 0, we have a vertical asymptote. If qc is 0 and pc is also a 0, then we have a hole, right? That is the other way of saying the same statement. But there are examples which contradict it. Let me give you the example right here. Consider this example. Let us say a rational function which is equals to, now instead of, let me take this as x minus 1 whole square, right? So let me take x minus 1 whole square in the denominator, and let me take x plus 1 times x minus 1 in the numerator. Now, will this rational function have a vertical asymptote at x equals to 1 or not? Decide about it. So at x equals to 1, we have q of c. So we are calling this as the polynomial numerator, that is the denominator, right? So in this form, we could write like this. So what we see here is that at x equals to 1, what we have here is q of 1 is equals to 0 and p of 1 is also equals to 0, right? What really happens here is one of these factors, it gets cancelled off. But even after cancelling, we have denominator x minus 1. So we still have vertical asymptote. Do you see that? So we still have vertical asymptote at x equals to 1. Do you see that? So this statement or this example contradicts the statement given to us. So here we do have a vertical asymptote in spite of the fact that at c equals to 1, both numerator and denominator are 0. Do you see that? So that is what you should keep in mind. So there are cases where the statement doesn't work, right? So this is a very good example to take. I hope it helps. Thank you and all the best.